Hey, grade 11s, and welcome back for lesson 3 on the cardiac cycle. Let's begin. So in today's lesson, you will learn about the cardiac cycle. So how does blood pass through our heart, and what are the muscles that are involved in powering that cycle? We have something called nodal tissue found in our heart, and the nodal tissue takes on the role of both, it's got muscular traits and also traits of the nervous system. So it's kind of able to initiate the heartbeat on its own accord. And then we're going to talk about kind of step by step the stages of the cardiac cycle and what's occurring at every bit of the way. We talked a little bit about how our heart muscle has the ability to function independently from our brain. So we don't have a piece in our brain that's telling our heart, to beat every, 60 times per minute. It has this rhythmic ability to do so on its own. But there's going to be situations where your brain needs to take over and control your heart rate. We're going to talk a little bit about heart murmurs and about arrhythmia, so kind of two conditions of the heart. One thing I want to note at the beginning of this lesson, in terms of assessment and giving you feedback on how you're doing, there is an assignment that goes along with lesson 3, but we'd also like to give you the choice of taking notes throughout the lesson. And if you just want to show that you've taken a good set of notes, that should be sufficient for us to know that you're following the material and you're keeping up. So a couple quick notes about note taking. You want to make sure that if you're looking back on this material and you're studying, that you're taking enough information that's going to give you an idea about what we covered, to keep them, neat and organized, so that, you're able to read it. And I acknowledge that people take notes of different fashion and different ways. So not necessarily going to be critiquing you on how well you're taking notes. If your note set works for you, that is what is important. So let's begin. So let's start with nodal tissue. So every time your heart beats, it undergoes a full cardiac cycle. And the cardiac cycle is initiated or signaled by nodal tissue. Nodal tissue is specialized muscular and nervous tissue that transmits impulses that causes the heart muscle to contract. We've got two nodes in our heart. We've got the sinoatrial node. It's located up here in the upper part of the right atrium. And then we've got our atrioventricular node, or AV node, located at the bottom of the right atrium. So our sinoatrial node, or SA node, it's located on the upper dorsal wall of the right atrium here. And it's going to send an impulse every 0.85 seconds that's going to cause the atria to contract. Note I didn't write atrium. It doesn't just cause the right atrium to contract, but it causes the whole upper heart, our upper portion of the heart to contract. The SA node is also called the pacemaker because it controls the rate of the cardiac cycle. It initiates that impulse. So down here we have our atrioventricular node, or AV node, and that impulse that's sent by the SA node is going to travel down to the AV node. And it's located at the base of the right atrium, close to the sternum of the heart. That's that area here that separates the left and the right side of the heart. So within the sternum, our atrioventricular bundles are also called the bundle of His, which are going to carry that impulse that started at the SA node down into this, to the bottom of your ventricle muscles, to these Purkinje fibers. I always trip up over that word. And these are going to cause your ventricular muscles to contract. So it starts up at the SA node, sends the signal down to the AV node, and these fibers, which are embedded in the heart muscle, are going to cause the ventricles to contract. So the cardiac cycle kind of has these two general phases. First, we have diastole, which is when your heart is filling with blood. And then we have systole, when your heart is contracting and pumping blood out through the pulmonary arteries and out through the aorta. So systole is the contraction of ventricular muscles, pictured on the right of this diagram here. Blood is ejected from the heart through the aorta and the pulmonary artery. Systole also describes the contraction of heart muscles. So your ventricles here are in systole, they are contracting. Whereas the opposite, diastole, is the relaxation of heart muscles. So you can see that everything's nice and relaxed. Here, blood is filling in through the chambers. It's coming in through the vena cava here. It's coming in through the pulmonary veins. And then when heart muscle is relaxed, we can say that it's diastole. So we've kind of got these two general phases to describe the cardiac cycle. Couple things to note here, if you can remember from chemistry class, that blood is going to move from an area of high pressure to an area of low pressure. If you can kind of imagine you have a somewhat deflated balloon in your hand and you squeeze it, you're going to apply pressure to one end and air is going to flow to the other. That's kind of how your heart muscle works. If your ventricles are squeezing, they're contracting, they're going to push blood out. And then the opposite is true when they relax. Blood is going to fill up that area again. So when contraction occurs, pressure of the chamber is increased. And then when relaxation occurs, pressure of the chamber is decreased, and blood's going to want to flow back in when the muscles are relaxed. So I've broken the cardiac cycle into 3 stages. This goes into pretty good layer, pretty good depth of information. So first we have atrial contraction. That's how it all begins, when our SA node fires for our atrium to contract. You'll notice here I have atrial systole and ventricular dystole. This denoted in the brackets here, that's just going to give you an idea of what what the upper and lower chambers are doing with respect to one another. So if the atrium are in systole, they're contracting. If the ventricles are diastole, they are relaxed. So just keep that in mind. We've got ventricular contraction. So now our atrium are relaxed, they're in diastole, but our ventricles are in systole and they're going to contract. And then we have this brief moment in time where all of the chambers are going to be relaxing and the cycle is able to reset. So if you look back to those 2 kind of general phases of systole and diastole, systole is going to be number 2 here. So when the ventricles are contracting, blood is exiting the heart, it's systole. And then when diastole is occurring, your atrium and your atrium are relaxed. We'll visit that again. So at the beginning of the phase here, we've got atrial contraction. This contraction is simulated by the SA node. Increased pressure of the atria, they're going to force your AV valves open, and blood's going to flow into the ventricles. And once blood exits that chamber there, what's going to happen, the decreased pressure in your atria are going to force those valves to snap shut. See there, blood's exiting and they snap shut. So if you can think about what a heartbeat sounds like, it kind of makes this lub-dub, lub-dub, lub-dub kind of sound. So those first valves snapping shut, that's going to create the lub sound. So when your AV valves, your tricuspid and bicuspid or mitral valve snap shut, it makes that lub sound. Next, we have our ventricle contraction. So at this point, our atria are relaxed, but our ventricles are going to contract. So your semilunar valves open when your ventricles contract, as you can see there, and blood is going to rush into the pulmonary arteries as well as into the aorta. And then once that kind of spurt of blood is pushed out through those vessels, the pressure is actually going to decrease in these vessels, and it's going to push your semilunar valves closed. So you see there, it's quite fast there. Pushes out, close. And then when those valves closed, it creates that dub sound. So keeping the diagram in mind here, we have lub, dub, lub, dub. Then there's a brief moment in time when both sets of chambers are going to be relaxed and the valves close momentarily together. Happens right here or here. So as blood begins to fill the atria through the vena cava as well as the pulmonary veins, it's going to increase your pressure in your atria, and that's going to force your AV valves open, and that's how the cycle repeats. So let's look at that again. Got the animation here. We've got I'll explain it in terms of systole and diastole. So we have our systole, diastole, systole, diastole, systole, diastole. So blood exiting, filling, exiting, filling. You get the hang of it. So, as mentioned before, our heart has the ability to beat on its own. Our brain doesn't have to tell our heart that it needs to beat, 60 times per minute when we're at rest. But there's going to be some situations where your brain is going to have to take over so that you're able to get enough oxygen to your muscles and to your organs. So the heartbeat can be influenced by something called the cardiac control center or just the cardiac center. And that's found in the medulla in your brainstem here. Um, and the cardiac center is it's part of what's called the autonomic nervous system. So the autonomic nervous system is subdivided into two categories. You have the parasympathetic nervous system, or the PSNS, and this initiates the rest and digest response, where the body is undergoing a resting state. You're probably in the rest and digest state as you are watching this video, unless you're watching it on a treadmill, which your body might be in a little more of the sympathetic reaction. But rest and digest, the body is undergoing regular metabolism, it's digesting food. So if you are kind of entering the state from a state of excitement, your parasympathetic nervous system would kind of kick in and tell your sinoatrial and your atrioventricular nodes in your heart to relax and to start decreasing the heart rate, because the heart doesn't need to pump as hard if you're in a state of rest and digest. And then we've got the opposite of the rest and digest. We have the sympathetic nervous system. And this is going to initiate this fight or flight response where the body is undergoing a state of increased activity or stress. My favorite fight or flight situation, when you think of it, you just feel it, is when you oversleep your alarm on an important day. You know, as soon as you wake up that you have something to do, it kind of everything goes by in a blur. You're not really taking in a lot of memory. You might skip breakfast by accident. You just have to get to where you're going to exit this state of stress. So when you enter the fight or flight response, your body is going to tell your SA and AV nodes to pick up the pace and to make the heart pump a little bit harder so that you can get nutrients to your tissues so that you can run and get to where you're going. So while you're scared, nervous, or excited, also fight or flight, adrenaline is released by the nervous system, and this is also going to help your heart rate increase and rate of blood flow to your muscles. Another thing your body can do, so when you're exercising, your muscle tissue needs more oxygen. Your blood and by doing so, your cells undergo cellular respiration, so you're going to be producing more of this waste product. Your body's going to pick up on that. And this increase is going to be detected by your medulla oblongata, and noradrenaline is going to be released. And that's going to cause your SA node to fire more rapidly, so your heartbeat can keep up with the demand of oxygen needed for your tissues. So there's a condition called a heart murmur, and a heart murmur is literally the sound of blood kind of swooshing around in your heart. So instead of passing through, something is going on. So it's often caused by a valve that is unable to close effectively. And a doctor is able to listen to your heart with a stethoscope, pictured here, nice pink stethoscope, and a heart murmur can be quite easily detected by a doctor. You can be born with a heart murmur, but it can also develop throughout your life. A heart murmur is not necessarily fatal or going to cause you a lot of problems, but there are conditions where a heart murmur can be a little more detrimental. We've got a condition called arrhythmia. And arrhythmia is a disorder of the nodal tissue of the heart. So that means that your nodal tissues aren't firing to a rate that's going to help you sustain enough oxygen to your body, or maybe too much. So arrhythmia can cause the heart to beat too quickly, too slowly, or just irregularly. And if you have arrhythmia and your heart is beating too slowly, that can be corrected with what's called an artificial pacemaker. So a pacemaker is this device that's going to be implanted into your body, near your collarbone. Sometimes they're outside your body, but often in. And this electrical node is going to come out of the pacemaker. It's going to be inserted through your blood vessels, and it's going to be set inside your heart. So the pacemaker is going to be monitoring your heart rate, and it's going to detect when your heart rate drops below a normal level. It's going to pick up on that, and it's going to stimulate your SA and AV nodes to fire, and that's going to increase your heart rate. If you have arrhythmia to the other degree, where your heartbeat is too fast, that can be controlled with medication, whereas a slow heartbeat is not as easily treated with medication. So let's review what we talked about today. What causes the heart muscle to contract? So that network of the nodal tissue with the SA node and the AV nodes, the bundle of His and the Purkinje fibers, that all comes together to help your heart muscle contract. So I'd like you to note that the SA and AV node are going to cause your atria to contract, but it is the atricular ventral bundles and the bundle of His, the Purkinje fibers, that are going to cause the lower half of your heart muscle to contract. What are the stages of the cardiac cycle? If you can summarize it in the systole to diastole, that is good. I went into the level of detail I did just to kind of give you a step-by-step so you can really pick it apart if you need. But if it comes down to just getting a basic understanding, knowing that systole is when your ventricles contract and blood is being ejected from the heart. And diastole is when the heart muscle relaxes and blood fills your atria. There we go, atrial contraction, ventricle contraction, and the chamber's relaxing. How does our brain influence heart rate and when? So talking about the autonomic nervous system, and we've got the parasympathetic, where our body is relaxed, we're having a meal and everything's okay. And then we've got the other situation where we might be running from a bear and our body needs lots of oxygen quickly to our body. Our heart rate needs to pick up to accommodate for this big change. So just thinking, how does our brain influence heart rate? And then what's going to happen if our nodal tissue is not functioning properly? So that's the case where you have a heartbeat that is too quick, so your heart's working a little bit too hard. And then you have the case where your heart might not be pumping fast enough. So you might not be getting enough oxygen to your body, and an artificial pacemaker might have to be implanted. As I mentioned before, if you've been taking notes throughout this video, you can always pause and go back if you missed something. I guess I should have mentioned that earlier. But if you choose to do the assignment instead, I've got a couple of questions for you here. I'll just go over them quickly. And if you're taking notes, I would just be mindful of these questions and maybe think about them if you're studying or wanting to improve your knowledge. So one thing you should be able to do is to describe the pathway of an impulse through the heart muscles. So where does that impulse start? Where does it travel to? And what chambers does each part act to contract? So remember that the SA node and the AV node are going to contract your atrium, and it's the bundle of His and the Purkinje fibers, I always get tripped up on that word, that are going to cause your ventricles to contract. To compare systole and diastole, so just talking about what is systole, what's happening, your ventricles are contracting and blood is exiting your heart through your aorta and your pulmonary artery. And then diastole is when your heart muscle is relaxing, your atria are being filled with blood, eventually your ventricles are being filled with blood, and that's where the cardiac cycle goes. What is meant by fight or flight mode? So what is the state? What causes it? What part of the autonomic nervous system? It is the sympathetic nervous system. And when would your body experience this? So just providing an example of, I'm running from a bear. I think I'm going to miss a flight. I've got an exam and I'm really nervous. I get a little nervous around tests too. And then how does your body react to accommodate the state? So your heart's going to be working a little bit quicker just to accommodate that extra need. So as always, if you have any questions or comments, concerns, you can reach me on Teams. I think I posted my new email. I'm in the system now, so please contact me on the River East Transcona School Division email. Thank you for watching. Appreciate your time.